All right, so this is going to be number 39 on page 610. And so you have 5 divided by 7, x to the 3/4. Now, last semester, your exponents were integers. This semester, your exponents are rational exponents. They're rational numbers. So that's why they're called rational. This section is called rational exponents. That's what this section is called. But the rules are the same. What you learned last semester, the rules apply here. So this is supposed to be negative 3/4 right here. All right, negative 3/4. Okay, so the direction says this. The direction says write this expression using positive exponents. So what does that tell me I've got to do here? Okay, so what's being raised to the negative exponent? The x. Everything else stays where it is. So where's that x to the negative 3/4 located right now? The denominator. Where must I bring it? The numerator. And that's where the sign of the exponent changes. So what would be the answer? 5 x to the 3/4 over 7. That would be the answer. Then we talked about this idea. This is going to be, let's say, number 19, where we had negative 64 raised to the 2/3 power. And the directions here says use radical notation to write each expression, then simplify it. All right, so the first thing I do is to rewrite this using radical notation. So negative 64 raised to the 2/3 power, when I write as a radical, is what? Okay, so you forgot. It's because you better note for the 27th, right? Okay. The denominator is your index. The numerator is your power. So this is going to be the cube root of negative 64. And where do I put that power? It doesn't matter. You can put it inside the radical or outside. It's usually best if you put it outside when simplified. What's the cube root of negative 64? Not 8. Negative 4.
Sorry.
And then I square negative 4, and what do we get?
Positive 16.
Positive 16. That's your answer. All right, and then number 33, you have negative 4 raised to the negative 3/2 power. All right, first of all, make the exponent positive. Before you change it to radical notation, make sure the exponent is positive. So how do I rewrite negative 4 raised to negative 3/2 power?
You gotta move it. I guess right now it's the numerator.
Okay, so where? How do you write it?
Move it to the number
So
1.
1 over, okay.
Yeah.
Negative 4 raised to what power?
3.
3/2. So whenever you move it from numerator to denominator to numerator, the sign of the exponent changes. Just the exponent. Notice the base stayed the same. It's still negative 4. Okay, so then I got to simplify. I got to change the negative 4 to 3/2 to radical notation. So let's go off to the side and kind of figure out what that would look like. Negative 4 to the 3/2 power. What's that?
Square root.
Square root of negative 4 all raised to the
Third power.
third. All right. Now the direction says, this was number 33. The direction says write with positive exponent, then simplify if possible. All right, so how do I simplify the square root of negative 4 to the third? See how I wrote where I had the cube root of negative 64? What's the cube root of negative 64? What number times itself 3 times is negative 64? Negative 4. And then I squared it, and that's how I got this. What's the square root of negative 4?
It's the 2 with the it's the I
Yeah, so the square root of negative 4 is not a real number, right?
until you make it with the the odd thing.
Okay, so here you're going to say not a real number. So in my math lab, there's going to be one or two where you're going to have to say not a real number. You cannot take the square root of a negative 4. No real number times itself is negative 4.
Correct.
Because a real number times itself is either positive or 0. 4 times 4 is positive. Negative 6.2 times negative 6.2 is positive. 0 times 0 is 0. Is it ever negative? No. So that's where, in a little while, we're going to start talking about imaginary numbers. All right, but in this section, you would say not a real number. All right, let's look at 44. All right, 44, you have y to the 4/3 times y to the negative 1/3. All right, so remember last semester, one of the properties you learned was the product rule. The product rule. And the product rule basically said that if you have a to the m times a to the n, a to the m times a to the n, so when you multiply like bases, see this base is a and this base is a, so they're the same base, right?
Mm-hmm.
When you multiply like bases, what do you do to those exponents? You add them. So it'll be a to the m plus n. All right, so here I am multiplying like bases. This base is y, this base is y. So according to the product rule, what do I do to those two exponents?
Add 'em.
I add them. Now last semester was easier because the exponents were integers. Here you're dealing with rational numbers, fractions. So you got to figure out what 4/3 plus negative 1/3 is. The denominators are the same, so that's easy to deal with. That's 3/3, which is what? 1. So now I'm going to ask, what is y to the 4/3 times y to the negative 1/3? All right, so if you see how you're not answering me, what you may is just y. What you may want to do is actually write in that step right here. So that's y to the 4/3 plus what?
Y to the
Negative 1/3.
1/3.
And then what's 4/3 plus negative 1/3?
1.
Y.
So that's
Y.
just y. The answer is y. Then let's see. What if you had? Okay, let's make this as example. All right. Suppose I had x to the 2/3 times x to the 5/3.
7/3, x to the 7/3.
So when you multiply, so do y'all agree I'm using the product rule? I'm multiplying like base. When you multiply like base, you do what to those exponents?
Add them.
So it's a base raised to the exponents, the sum of the exponents. And so that's just 7/3.
Yes, sir.
Okay? What about if you had this one? X to the negative 6/7 times x to the 1/7.
X to the negative 5/7.
Okay, so x to the negative 5/7. So you're saying you're multiplying like bases, so using the product rule. Multiply like bases, you add exponents. So that's negative 6/7 plus 1/7. So that's x to the negative 5/7. But the direction says write using positive exponents.
So then.
So it's the answer.
1 over x to the 5/7.
Okay. All right. So that's a product rule. All right. So then let's talk about the power rule. So last semester you talked about the power rule. So the power rule looks like this. You have a to the m raised to the n. A to the m raised to the n. So basically you have parentheses involved. And so what you have inside this parentheses being raised to another exponent. So you see you have an exponent raised to, this has an exponent and the outside is an exponent. So when you have a power raised to a power, what do you do to those exponents? Do you remember? You multiply them. So this would be a to the m times n. So the power rule, you're going to multiply those exponents. So for example, if you had this, x to the 2/3 raised to the 1/5, let's say, that's the product, I'm sorry, that's the power rule. So that's going to be, so in your mind, you're saying x to the 2/3 times 1/5, right?
Right. You're gonna have to do a lowest common denominator.
No.
Top times top, bottom.
You only
times-
do the LCD when you add or subtract.
Oh,
So it'd be x to the 2/15.
X to the 2/15. And the exponent's positive, so you're done. All right. So here, the power rule again. So in your mind, you're saying x to the negative 3/4 times 2/5.
X to the negative 6/20, which reduces down to x to the negative 3/10, which you have to write 1 over x to the 3/10.
All right. So you get 3/4 times 2/5, which is negative 6/20, right?
Mm-hmm.
Reduce, you get negative 3/10, but you don't want your answers with negative exponents.
1 over x to the 3/10.
So it's 1 over x to the 3/10. Okay. So that's a power rule. Now, right after you discussed the power rule, you then discussed something called the power of a product rule. The power of a product rule. And the power of a product rule looks like this. A to the m, b to the n, all raised to, let's say, the x power. I made that up. Okay, so you see you have a power of a product.
Mm-hmm.
Okay, the power of a product rule says this. I take each factor, see how I'm underlining the factors? I take each factor and I raise to that exponent. So I have a to the m raised to what power?
X.
The x, and then I have b to the n raised to the
X.
x. So that's the power of a product. But notice that the power of a product becomes the power rule. See this?
Yeah.
And so the power rule, then now using the power rule, that's going to be a to what power?
BM plus
M
Or
times x,
mx
b to the
N.
nx. Okay? All right, so now let's look at number all right, number 50. That is number 50. All right, 50, you have this. You have 32 to the 1/5 times x to the 2/3. And all that's being raised to the third power.
Okay.
Pull down here.
Okay. So
32.
All right, so what property or what rule are you going to use right off
Powers.
power of a product? So the power of product then says I take each of these factors, so 32 to the 1/5, and I raise it to the outer power. So that's 32 to the 1/5 cubed, and then it's x to the 2/3 cubed.
And then you
Okay? And then what property did I use next? So to go from here to here,
power rule.
I use the power of a product. And then now I'm going to use the power rule. So when you have a power, it's a power, you do what to those
1/5
powers?
times 3,
So it's 32 to what power?
3/5,
3/5. And what's 2/3 times 3?
6/3,
Which is
2.
2. Make sure you understand that it's just x squared. 2/3 times 3 is just 6/3.
Mhm.
2/3 times 3 over 1, right?
Correct.
6/3, which is 2. Okay, now let's deal with 32 to 3/2, because it does say simplify if possible. So let's think about 32 to the 3/5 power.
So
Let's see if I can simplify this.
the index is 5.
Hmm?
The index is 5.
Okay, so that's so you're kind of saying the fifth root of 32
The third power.
raised to the third power, right? So in your mind, you're thinking, okay, now can I simplify the fifth root of 32? Is there a number times itself 5 times? That's 32.
I don't think.
Unless it's a decimal.
Huh?
I don't think so.
2.
Oh.
2 times 2 times 2 times 2 times 2 is 32.
So we can make calculators for.
Now, notice what he said. He says, I'm just using a calculator. No, you do have access on a calculator. So if you take your calculator out, I'll just show you how to figure out if that's a. Now, if it turns out to be a decimal, don't write as a decimal. Just leave it like that. But if you can simplify. But you do need to know that 2 times itself 5 times is 32. So this would be this right here. Then would be 2 to the third power, which would be what?
8.
8. So then this answer would be what?
8 times
X
or 8x squared.
8x squared. But on your calculator, if you just say 32 raised to the now you got to be careful because see what you're going to do is you're going to say 32 raised to the 3 divided by 5 like this, right? That's what you would probably say.
Pull it down a little bit so it's 16.
That's what you'd say. Now if you press enter, you don't get
Yeah.
2. You get this.
Okay.
That's what you get. Because when you input in the calculator, what you're telling the calculator to do is take 32, raise to the third power, and whatever that is, divide by 5.
Yeah, you'd have to
So what is it I got to do to make sure I get the right answer?
parentheses.
Parentheses around the exponent. Okay. So you can say 32 raised to parentheses 3 divided by 5, close the parentheses, and then press equal, and now you get 8. Okay? All right, so just make sure if you use your calculator correctly. All right, so that's 50. All right, so then we talked about the quotient rule last semester. So the quotient rule basically says this. If you have a to the m power divided by a to the n power, quotient, you're dividing. So in the product rule, when you multiply like base, you divide to those exponents. No. Product rule, when you multiply like base, you divide to those exponents. You added them. The quotient rule, when you divide like bases, you do what to those exponents? Subtract them. So it's the base raised to the m minus n. So as an example, suppose I had x to the 2/3 divided by x to the let's say 4/5. All right.
Now you got to do LCD.
But you can use your calculator for that. All right, so x to the 2/3 divided by x to the 4/5. So what rule do I need to use?
Quotient rule.
Quotient rule. So that's going to be your base, which is x, raised to the 2/3 subtract what?
4/5.
4/5. So on your calculator, what's 2/3 subtract 4/5? So 2 divided by 3, subtract 4 divided by 5, press equal.
Put parentheses, huh?
No, not here. You don't have to.
We can't see it on your screen. But,
Looks like this.
so
Now it's a decimal, 4/5. It's a decimal, so how do you change back to a fraction?
the second
PRB,
yeah,
press equal, and so what do you get?
negative 215.
Negative 2/15. So this becomes x to what power?
Negative 215 power.
No negative exponents, so what's the answer?
1 over.
1 over x to the 215.
Okay, there's your answer. Okay? Okay, now, let's look at 52. Now listen carefully as we do 52. you have a to the 1/4 times a to the negative 1/2 divided by a to the 2/3. Don't make it difficult. So, what might you want to do first?
Take care of the top.
Take care of the top.
Okay, deal with the numerator first. That's what I would do first. So in the numerator, if I cover the denominator up, what rule are you using? Product rule.
Just add
Okay.
a bunch.
So the product rule says that when you multiply like base, you do it to those exponents.
You add.
You add them. So on your calculator, so I'm adding 1/4 and a negative 1/2, right?
Mm-hmm.
Okay. And all that is being divided by a to the 2/3?
Mm-hmm.
All right, so let's deal with the numerator. So what's 1/4 plus a negative 1/2 in your calculator?
Negative 1/4.
Okay, y'all get negative 1/4? Use your calculator. You're not going to have time in the test to do it by hand. So learn to use your calculator. What's 1/4 plus a negative 1/2?
Negative 1/4.
Negative 1/4. So that's a to the negative 1/4 divided by a to the 2/3.
Then you subtract.
Okay, now, so right off, I use the product rule. Now I've got to use what rule?
That's a 2/3.
What rule? You answer my question. That is 2/3. Yes, it is 2/3.
The
Quotient rule. So the quotient rule says that when I divide like bases, I do what to those exponents?
You
Subtract. So that's negative 1/4 subtract a what?
2/3.
2/3.
Which
Now,
is a negative 11/12.
all right. Now on your calculator, you're going to say negative 1/4 subtract 2/3, press equal. Change that decimal to a fraction. Make sure you're using your calculator. Make sure you know how to do this. And
There's
you
a
should
few
get,
calculators where you can just put in fractions though.
and so what fractions you get?
Negative 11/12.
Did y'all get negative 11/12? Is there only one person that's using a calculator right now? Okay, just one person using a calculator, right? So the rest of you know how to do it though, right? You what? Huh?
It is right.
Well, girl, you need some trifocals then. Go ask for trifocals. Not only does she have hot flashes, she has trifocals she needs.
Trifocal. That's the first one I've heard that.
No, a lady at work has trifocals.
So 1 over a.
And look,
Yeah, it's going to be
the
1 over
the
a,
room
11/12.
temperature, you and her are alike because the room temperature is like 30 degrees because she gets hot all the time.
1 over a.
1
is
over
the
a
11/12.
11/12.
All right. Okay. All right. Now let's look at this one. All right. So this is 56. 56. Don't make it difficult. Very simple. Okay, 56. You have 2x to the 1/5.
You can't see.
2x to the 1/5 looks like this in parentheses, and that's being raised to the 4th power divided by x to the 3/10. All right,
Take care of the numerator.
take care of the numerator. Now in the numerator, if I cover the denominator, what rule are you going to be using?
Power.
Well, at some point you will, but really, technically, it's a power of a product. So the power of products, you have a product here? So now you're going to say, all right, since I'm using the power of product, then I'm going to take each factor and we raise to what power?
4.
The 4th. So in your mind, you're really saying 2 to the 4th times x to the 1/4 to the what?
4.
4th, all divided by x to the 3/10. And now in the numerator, you're going to use the power rule.
Okay, so
What's 2 to the 4th?
2 to the 4, 2 to the 4,
16.
16.
16. What's x to the 1/4 raised to the 4th?
X.
Yeah, 1/4 times 4
X
is,
to the 4th.
no, not x to the
No.
4th,
1/4 times 4 is
is 1.
So x times 1 is x. So you get 16x
So
over
x.
x over 3/10.
16x
Or
divided
to the
by
3/10 power.
x to the 3/10.
Sorry.
So 1/4 times 4 is 1.
Yeah.
Okay, so that's x to the first.
Wait, I'm sorry, Professor. Didn't you say that was a 5 to begin with?
Yeah, 1/5.
So we totally.
Oh, I'm
Unless
sorry.
you want to leave it a
No.
4, and then that makes everything right. But
So that's
it-
what,
it did
4
look like
fifths?
yeah, 4/5.
4 fifths. So that's a 5 right here.
Yeah. I should have said something. I didn't think about it.
All right.
Okay.
Okay, so that's 1/5. All right, so 1/5 times 4 is 4 fifths, right?
Mm-hmm.
Okay, so now what rule do I need to use next? Quotient rule with these, correct?
Subtract them.
So that becomes 16 times x to the 4 fifths subtract
3.
3/10. Now use your calculator for that subtraction.
4 fifths.
4 fifths subtract 3/10.
3/10 equals
16x to the
1/2.
5/10,
One
which
half?
equals a
1/2.
half.
So there's your answer. You're done. Okay? That's 56. Okay. 58. 58. It's not difficult. Just remember your rules. Numerator, m squared, n, raised to the 1/4, divided by m to the negative 1/2, times n to the 5/8. What are you going to deal with first?
The numerator,
All right, so that's a power of a
power of product.
product.
Yeah.
So in your mind,
Part
you're
gotta be
saying
multiplied by 1/4.
m squared to the 1/4 times n to the
1/4.
1/4. And then just rewrite the denominator, m to the negative 1/2, n to the 5/8. Okay, so I took, in the numerator, that's a power of a product. Now I'm going to use the power rule next. So what's m squared to the 1/4? So remember you're saying 2 times a fourth. That's 1/2. That's 2/4, which is 1/2, right?
Mhm.
So you'd all agree that's m to the 1/2?
Yeah.
Yes,
N to what power?
it's just the power.
N to what power?
Oh, n to 1 is
N to
1/4.
1/4. Divided by m to the negative 1/2 times n to the 5/8. All right, so that's where I'm at. So to go from here to here, I use the power product, and to go from here to here, I use the power
Power
rule.
quotient.
Now I'm going to use what rule?
Quotient.
Quotient. So use a quotient rule with the base m's, and use a quotient rule with the base n's.
I can't read that.
So use your glasses. So that's m to the 1/2 subtract what?
1/2.
No.
Oh,
Negative 1/2.
So you're gonna add.
Times n to the 1/4 subtract what?
5/8.
5/8. Okay, use your calculator. What's 1/2 subtract a negative 1/2 in your calculator?
Why should be
It's just
1?
1.
Minus a negative is plus a positive.
Right. But you have access to a calculator.
So you have m.
So it's m, just m, right?
By itself, yes.
Okay, now the n.
So 1.
What's 1/4 subtract 5/8?
Negative 3/8.
Negative 3/8?
Yes.
Is negative 3/8.
Is that the answer?
No. You gotta,
Why not?
Because you got to remove.
It's got a
it.
negative.
Yeah.
You want your exponents to
1
be
over
positive. So what is the answer? You got to write your answer as one fraction now.
1 over.
Okay, so what he's doing is this. I'm assuming that's what he's doing. He's saying that's m times, and then this becomes what? 1 over n to the 3/8. But don't leave your answer like that. Your answer has to be written as one fraction. So now rewrite this as one fraction. What's the numerator?
Oh, m
M.
over n to the 3/8.
All right, make sure you understand what I just said. Don't leave your answer like this. You'll be upset. You got to write your answer as one fraction. Okay? All right. Okay, now let's look at this. This is 62. We're almost done with this section. It's not a difficult section.
Just a lot of different rules to remember.
That's correct.
Can you pull it down again, please?
X to the 1/2. It looks like this. Okay, that's what it looks like. What?
Is the last one a 3 halves?
Yeah.
Okay.
What do you think you're going to use here? The distributive property. Very good. All right. So you can just use distributive property.
So. that's
Distributive
1/2
property.
times 1/2.
No, no, no. He said 1/2 times 1/2. Is that true? Is he going to say? Is he going to say that's x to the 1/4? No, that's wrong. So he's trying to do things in his head,
Well, yeah.
and for him, sometimes it causes trouble. What he should have done first.
Use calculator.
No, no, because you still would have said 1/4 times 1/4. What you should have done first was the distributive property. That's x to the 1/2 times x to the what? 1/2 plus x to the 1/2 times what? X to the 3/2. That's what he should have done first in his mind, but I don't think that's what he was thinking of. Now, so I used a distributive property. What's the next rule that I use?
The
Power.
no, it's
No.
not that.
It starts with a P.
Product.
Product rule. When you multiply like bases, we do the exponents.
Add.
Add 'em.
You add them. So instead of saying 1/2 times 1/2 like he said,
You would
he
just
should have
1/2
said 1/2 plus 1/2.
It's a 1.
So that's
So
just
X.
x. Okay. Over here, you're using a product rule again, right? The product rule again, right? So what's 1/2 plus 3/2?
4 halves,
Which is 2. So x squared, x plus x squared. And that's it. There's your answer. I've got that. Let's do one more with this. This is going to be 64. 64, you have 3x to the 1/2 times x plus y.
Distributive property again.
So distributive property. So in your mind, you're saying 3x to the 1/2 times x plus 3x to the 1/2 times
Y.
y. So I use distributive property. Now, for this part right here, what rule would I use that I'm circling?
Product.
Product rule.
So you add the 1 to the 1.
1/2 plus 1.
So
Don't leave it as a mixed number. Tell me what fraction that is.
3 over 2.
3 over 2. Y'all agree? Use your calculator. What's 1/2 plus 1 in the calculator? Should I agree that's 3 times x to the 3/2?
Mhm.
What rule do I use here? See how I was able to simplify this using the product rule? How do I simplify this?
It's not like terms, so you can't.
All right, so there's no rule that you apply here, so you just rewrite it. 3x to the 1/2 times y. There's your answer. You see, this right here, you couldn't use any rules because the bases are different. This is x and this is what?
Y.
Y. Bases are different. Okay? So that's it. There's your answer. All right, so. Okay, let's see with this section.